As you know, many glaciers strongly retreat, especially also in the European Alps. And to understand what the impact is on the glacial retreat on the adjacent valley slopes can be important. Not for all valleys, not for all glaciers, but for the Great Aletsch Glacier, for example, we have a big meltwater river at the tongue of the glacier, which is the Massa River. And if the retreat of the glacier triggers big landslides, these landslides can form a natural dam for the Massa River, creating possibly a big lake. And if the dam breaches, there would be a huge flood. And in the case of the Great Aletsch Glacier, this flood might not only reach a hydropower lake, the Gibidum Lake. This flood might also overtop the dam of this hydropower lake and impact a big city, the city of Brig. This is not the case. This is important, for all the valley glaciers, only for very special, geographic locations. The processes which happen when a glacier retreats, like what we observe in many places today in the world, are much more complicated than what the geologists and geomorphologists and glaciologists thought before we started this program. Before we submitted this proposal to the Swiss National Science Foundation, we visited several valley glaciers in the Swiss Alps, not only the Great Aletsch Glacier, but finally we decided to work near the tongue of the Great Aletsch Glacier because the history of this glacier has been studied by many researchers in the past. So we know and we knew at the beginning of the project a lot what had happened to the Great Aletsch Glacier since, let's say, the last glaciation in great detail. In our research project, we did not only classical field mapping, as geologists and geomorphologists often do, but we also, and this is quite unique, installed sensors. And we installed very complex network of sensors on ground, mainly on the adjacent slopes, also on the glacier itself and within boreholes. So we drilled into the slope and we drilled into the glacier and we installed a lot of monitoring devices. I'm very happy with the results of this 10-year-long project. I have to say that in this long period, 4 PhDs were completed, all by very great scientists. And we also worked with about a dozen of master and bachelor students. So we created a huge amount of very valuable results, and I cannot explain them here. I just would like to maybe identify 3 major discoveries. In this project, we worked on the interaction between a valley glacier and something which we call a mature landslide. So landslides which were already there a long time ago, in our case, at least since the last glaciation. But we also worked on stable slopes adjacent to these landslides. So for example, the impact of a retreating glacier on a mature landslide was studied in great detail, and it was really impressive to see the diverse reactions of different types of landslides to the retreat of a valley glacier. And it was also really impressive to see how strong some landslides reacted to a retreating valley glacier. Especially strong reactions were seen and monitored in great detail when the ice level was melting down from the landslide toe. So at a relatively late stage of a valley glacier retreat. When we looked into the response of stable valley slopes on the retreating Great Aletsch Glacier, we saw impressive deformations which were completely unexpected. in the order of up to a few centimeter downslope displacement per year in a stable slope. And we also observed ongoing damage, so fracturing in the adjacent slope. And we found out that this deformation and damage is not only related to unloading of the valley slope by the reducing weight of the glacial ice, we could also see that there are very strong hydraulic interactions between the valley glacier and the slope, causing significant amounts of damage. In a glacier, we have daily meltwater pressure fluctuations, which have a very high amplitude. And these high daily pressure amplitudes can also be observed in the slope, causing significant deformation along fractures. At the moment, two important open questions come to my mind. The first question relates to the interface between the valley glacier and the rock slope. We know very little about this interface because we can just observe it along a line, at the boundary on land surface, and we can observe it maybe with a few boreholes. We also drilled boreholes through this interface, but these are only informations at the extremely small scale which you get. So we do not really know what are the materials and the material properties at this interface, and how do, for example, pore pressures migrate along this interface or migrate from the ice into the rock slope. Another question, but this is a very hard question to resolve, is what happens in the period between initial deformation in a stable slope and a mature landslide. So we could observe the response of these two kind of end members in our project, but we do not know in detail how a damaging stable slope develops into a real mature landslide. This is also something which could happen over very long time scales, so it might be extremely difficult to get hard observational data about this transition, but it's still an important question to me.